Welcome back to School of Civil Engineering. This is Hidayatullah with another new video. As we have started the Quick Suite tutorial series, and in our previous video I have shown you that how we'll design a beam or how we'll design a column. So in this tutorial I am going to show you that how we'll design a concrete wall. Suppose you want to create some wall for your construction work or for some anything, or you can you want to create a drop wall, like a drop wall. So how we'll do that? So in this video I'm going to show you that. So let's start. And if you're new here, you can watch our previous video. That link are given in description. And if you're a civil engineer, don't forget to subscribe to our channel. So first of all, from here, this is the first software we are using. This is the Quick Suite software, and in first video I have discussed about the software and I have shown you that how will work here. So this is the quick machinery software QM. Here the quick component design, wall, beam, column and plasters. So after that, here quick concrete wall. Here is the quick concrete wall and it's showing reinforced concrete shear wall design. So if you want to design a wall by clicking by using that, we'll design that. So first of all, click here and I will zoom it, and these are software. So from here I have discussed about the all toolbar in our first video, so I think you can watch that. And this software name is Quick Concrete Wall 4.0 version, and it's Quick Concrete Wall. The version 5 are available in CSI website, so I think you can download from that. So if I see you, so IES software, from IES software you can download it. So this is the free version. I am using that. This is a free version. Also you can download that. So if you need that and or if you tell me that you need to download the software, then how will get the software, I will show you. So first of all, there have two options: double curtain wall and single curtain wall. What is the meaning of that? That means this is a single curtain wall. They have only one wall and with a single line reinforcement. And here double curtain wall, this is the for double reinforcement. So first of all, in this lecture I am going to show you that about single curtain wall. So we'll click here, and after that you can give here any name. So just give the name, and after that click OK. So it's here, and in our first video I have shown you that when you will work here, you will see here the result here. Okay, you will see the result here, and if this sign, this blue sign represent that it's okay, and if the red sign, that means it's not okay. So first of all, we'll here you can click here. This is the input value, and here is the check value. You can check that everything is okay or not. So we'll go here, input view. So from here, criteria. When we'll go for criteria, then building code, we have to select building code. So there have only available code is international building code. I will select 2012. They have the any version, you can do that. Then load combination, from here you can select load combination any one. So I'm going to select about ASCE 710. you can use that, or you can also use that. So let's use that. After that, use seismic provision. Here use seismic provision. If you want to use seismic load for it, then you have to cross here, otherwise do not use. So click here. After that, apply chapter 11 shear check. So from IBC, this is the chapter 11 for shear check. So here for shear check, for the case where the ACI chapter 21 seismic provision apply, this option case the program to also consider the chapter 11 provision when the performing share check the chapter 11 provision are more restrictive in some case. So actually you can read everything from here that what you are doing here. So after that, design displacement, here is the design displacement. What is the maximum displacement you want to consider? So I will consider displacement, suppose 2 inch. 2 inch, here is the design displacement. If you see here, the total lateral displacement explained for the design based earthquake as specified by governing code of earthquake testing design. So for ACI 31802, this is delta U as defined in 21 inch. Okay, so 21 is subsequent ACI code is defined in section 2.1. so from here you can read that what is the maximum allowable. So I will give here suppose 2 inch. I will allow that my wall will deflect maximum 2 inch. So at the time of earthquake, then use phi 0.6 for shear roll. So use phi 0.6 for shear. After that, here is the materials property fc prime. What will be the fc prime? I will consider this is 3 ksi, and this is the reinforcement and unit weight. Here is the unit weight of our wall. So okay, wall unit weight, so consider this is it's okay 145, and you can change that according to concrete unit weight, I mean according to materials unit weight. Then apply wall weight. Yes, apply wall weight. Then shear is at wall top. So if you do not select that, it will do not consider any shear on its top, but if you select that, it will consider shear on its top. Suppose uh, if you have a wall with a vertical load, then it will consider it. Okay, so we have done that. After that, we'll go here or loading. Okay, after coming here, we have to add load in our wall. So you are seeing that figure. Here is a column, here is a column, and here is our wall. So this is the vertical force, and this is the concentrate, I mean upper load. Suppose you are using a uh, wall, and on it you will provide a slab. So and then this pilot will work, and here is the moment. Okay, so for that, after that we'll click here add. Okay, so to load add load, we have to click here add. So click here add, and here is the load. So source, which types of load we are providing? So first of all, our dead load. So axial force, what is the axial force? This is the p is the axial force. So what is the axial force on our wall? Suppose if you consider the axial force is 15 kip, then if have any moment, what is the moment in plane? So if there have any moment, you have to give here. Suppose if we consider I have a moment of 10 kip feet. Okay, then here shear force, if there have any shear force here, so you can give it here. Suppose we have shear force of 5 kip. Okay, then press OK. After that, again add, then we'll add live load if there have any live load. So then press live load, then give here suppose live load it's 20 kip. Just I'm just giving a random value. So suppose it's 10, and the shear force it's 4 kip. So okay, I'm just going to show you that I will just work here. So we have provided our load, then we'll go here wall. So here we'll give the value. You can see its elevation, our here. So after that, we'll just go here and we'll give here the value. So first of all, if we may see here length, here the length, what is the length, or what is the length of our wall? So this is the length, and this is the thickness. So what is the length? Suppose if we consider our wall length is okay, let it go 20, and our wall height is suppose it's 10 feet. then our thickness is suppose 10 inch 10 inch thickness, and wall cover, what is the clear cover of wall? Okay, so wall cover 0.5 inch, let it like that. Okay, take it 0.75 as this, so 0.75. Now that is the important thing, and just see that when we are changing that value, these value are also changing. And now mm, here the vertical bar size, what is the vertical bar size? This is the vertical bar size, here on, here on, here on, this is the vertical bar size. Okay, so what will be the vertical bar size? Suppose if we consider the vertical bar size is 4, just see that when if I use 3 here, the vertical uh, ROS is it's failing. Okay, this failing, I mean this is not okay, it's showing the cross. So if we use vertical 4 bar, so now it's okay. So when you will do the work, it will show you your result here instantly. This is the good sign of this software, that you can make your project, or you can make your element as much as economical. So after that, vertical bar spacing, what is the bar spacing of vertical? So if we give here 12 inch is very much, so if we give here 10 inch, okay, so if we give here 10 inch, and horizontal bar size, what is the horizontal bar size? Suppose it will be 4 bar, and its bar size is also 10 inch. Just see that it's also okay. So if we consider our bar size is 4 inch and 4 inch, sorry, number 4 bar, but it will be 12, it's also okay. And if we consider it's 12, then it's all sorry, here, so here see that when we have increase the bar spacing, horizontal bar spacing in 10 inch, then our horizontal bar ratio is not okay. So if I go here 12 inch, sorry, 10 inch, 0 10 inch, then it's okay. So after that, horizontal bar anchorage, if you have any horizontal bar anchorage, so you can provide here. Okay, so suppose they have horizontal bar anchorage 90-degree hook, they like that. Okay, 90-degree hook for horizontal bar anchorage 90-degree hook, or a straight bar, or 90-degree hook, or you can provide here, provide confinement at the wall end. Okay, you can also provide the confinement at wall end. So just see here, it's showing you. So after that, if we click here, so it's not showing anything, but if you click here, just it's showing you that 45 inch confinement. Okay, so it will be the 45 inch confinement. So if we use confinement, tie size, then tie spacing, and extra confinement. Okay, so extent to confinement, so what is the extent of your confinement? You can use 1 feet, so 12 inch, suppose it's 12 inch, here is the confinement here. And if you give the bar spacing here, now suppose it's number 3 bar, and spacing 4 4. And here is the one thing, suppose if you have end of your column end of your work, so if we consider that we have no confinement, but we can use that, we have some we have column in two side of our walls, so click here, we have column, so like that. So you can use the column. Suppose you are working with a suppose you are working with a you are working for a drop wall, so you need to design a drop wall. So in this way you can design that. So after that, the column, so column length, what is the column length? So you have to give here 2.5 feet. Okay, column length is 2.5 feet. So we'll give here, our column is 18, sorry, 18 inch, 1.5 feet is the column in that direction. And if we consider the column thickness, this is the column in that direction represent column length, and here is the column sorry, here column thickness. This is suppose it's also 1 point sorry, it's 18 inch. So here is a column dimension. And now either if you can give her the parallel bar size count. What is the parallel bar size count? What will be the bar size in parallel? Okay, so if we see that our parallel bar will be suppose it will be 2. If we give here 2 1 2, and if we give the perpendicular bar size here also 2, just see here in this direction 2, and in this direction it's also 2. Also you can increase that here if you need that. So here bar size, what is the bar size? It's given 11, number 11 bar will decrease the number 5 bar. Just now see here the tie spacing are the maximum, so we have to increase the tie spacing. Here's the uh, tie size number 3 bar. Okay, number 3 bar will use tie, and tie spacing will, if we use 10 inch, so just see that it's okay. And column cover, what is the column clear cover? 1.5 inch, or you can it's 1.5 inch. So now here a special boundary element, if you have a special boundary element, so you can also click here. So for a special boundary element, if you can increase the rod, I mean river, here it will increase river here. If you have a special boundary, here is 1, and here is 1. So suppose um, where there are no special boundary elements, and where there are special boundary element. Suppose you have if you need the special boundary element, I mean if you need to give it, suppose here you can give it the extra reinforcement here. Here you can give it extra reinforcement, and also here you can give a extra reinforcement. Okay, like that. So for that you can use that, and you can increase or decrease your data. So in this way you can design a drop all or a share all very easily. Okay, so here you can draw a wall from here. So and if we see that data, now we need to now we need to this data as a PDF file. So you have to click here print. If we see in that view, this is the elevation view and wall. So here is the wall, and if we need to increase the data, so here if we need to print our design, so click here print option, and here Adobe, then wall. Okay, then press OK. After from your down, from your toolbar, you have to click here and save anywhere. Suppose save it, and then it's saving, so it's done. So now see here it's showing you everything here is your design. Okay, this is where SB is required and where SB is not required. So here is a design where SB is not required. For a special element you can design for it, and for a special sorry, here is the element for a special requirement is not required, but here a special requirement is required. So here, and if you see that all check are okay, here is the check name, so check summary. Okay, and here is a criteria, and from here you can see every calculation also from here. So like that way you can design a concrete wall that you require for any work and any purpose. So I think it was helpful for you, and if you also think that was helpful for you, don't forget to subscribe to our channel, and like our video, and share as much as possible our video. Your on like and on share inspire us for the next one. So thank you very much. Stay well, stay connected till next video.